Hey everybody, today we're going to look at the AP Calc free response questions on the AB exam from last year, from 2017. Of course, if this is in the future, then last year is the wrong. Anyway, from 2017. I'm going through these as blind as I can so that I can kind of review my thought process and show how I would tackle things. Remember that since there are 6 questions, we have a half an hour for the first 2 and then an hour for the second 3. You have 15 minutes per question. So I'm going to try to hold myself to that time limit, and I'm going to hold myself to whatever restrictions that they impose on me, such as on the first 2 questions are calculator, and the second 2 questions are not calculator. And as I speak, I am looking for my calculator because I'm a dummy. Well, I'll just have to find it when I need it. So anyway, here we go. It says, first question. Notice how it says 2 questions, 30 minutes, section 2, part A, whatever. A graphing calculator is required, not even allowed, but required for these questions. Okay. So notice how there's not really any room here for me to do my work. So I'm going to use this paper to do my work. So we're given this nice little table, and then I see a tank has a height of 10 feet. The area of the horizontal cross section of the tank at height h is given by the function a, where a of h is measured in square feet. The function a is continuous and decreases as h increases. Selected values for a of h are given in the table above. So if we check this out, we know it's continuous. That's really important. You may notice these underlines. I started doing this the other day and then I ran out of time, so I just thought I'd start from the beginning because I really only read the question. A is continuous and decreases as h increases. So we notice h is going 0, 2, 5, 10, and a is going down. And since we know that a is decreasing, that means between 50 and 14, it doesn't like jump up to 51 and then come down to 14, and it doesn't go from 14 like up to 20 then back down to 6.5. We know it's continually falling. We don't know how fast it's falling, but we know it's falling. So it says use a left Riemann sum with the 3 subintervals indicated by the data in the table to approximate the volume of the tank. Indicate units of measure. Okay, so if I'm using a left Riemann sum, you know, we can even think about this. So part A. Also, I'm going to try using marker because I was watching back a video and it was kind of hard to see what I was writing. So we'll see how this works. I'm learning and experimenting as I go. So if I think about these, I've got 0, 2, 5, and 10. And then I've got 50, 14, 6.5, and 2. So I've got here, here, nope, I'm sorry, here, 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 and here. So remember, the left-hand Riemann sum would be, I'm going to use this height and make a rectangle, this height and make a rectangle, and this height and make a rectangle. Okay, so my first rectangle has a base of 2 and a height of 50.3. My second one has a base of, now check it out, it's not 2, 2, 2 each time. This one, the base is 3 and the height is 14.47. I mean 14.4, I don't know where I got the 7 from. And then the last one has a base of 5 and a height of 6.5. Now, if it had asked for a right-hand Riemann sum, I would wind up using the right-hand values of each of these rectangles. So I'll go in and I will use my calculator because I'm not going to waste my time doing this by hand. But wait, let's say the area under this curve a wild calculator appears. Okay, so 2 times 50.3 plus 3 times 14.4 plus 5 times 6.5. All right, so I got 176.3, but if you remember, it says that this is a cross section, and that each of these numbers is an actual area. So we're integrating area. So we're integrating area with respect to h. And so this is going to be feet cubed. On questions like this, when it says indicate units of measure, that usually means that this part A is worth 2 points. 1 point for getting the answer and another point for writing feet cubed. Now, I'm going to cheat as I go and make sure that I did not make any blunders. Oh, I should have written from 0 to 10. Now, it doesn't ask you to write this part, so if I hadn't written that, that'd be fine. All right, let's check it out. Yeah, so out of the 9 points this question is worth, 1 of the points is solely dedicated to units. So that's pretty sweet, unless you forget them and then you lose that point. So let's move on to part B. Part B says, does the approximation in part A overestimate or underestimate the volume of the tank? Explain your reasoning. Okay, well, if I know that we are decreasing at the very best, you know, something, you know, I don't know exactly what this looks like, but I do know that it's always going down. So if we think about that, since it's decreasing, it's, you know, these areas are going to be overestimates. That is not a good enough answer. So I would need to show something that really helps me. So in part B, it's an overestimate. And my reasoning, this picture is not good enough. So I would need to make sure I state that since A is decreasing. Overestimate since A is decreasing and we are using a left Riemann sum. I forgot how to spell Riemann for a second. Oh, I was right. R-I-E-M-A-N-N. So, I wasn't sure exactly what to use. I cheated and looked at the answer. I thought we were going to need to say more about how since it's decreasing, we know that it's going to be, the left hand is always going to be using a high point, and then it's going to be going down to the next one, but that's fine. I'm so eloquent. All right, let's see. Part C. The area in square feet of the horizontal cross section at height h feet is modeled by the function given by blah. Based on this model, find the volume of the tank. Okay, so in part C, instead of this table up here, they're saying now this is my horizontal cross section. So if we integrate area, we get volume. So all I need to do is integrate f of h dh from 0 to 10. And here's the funny thing. That's all I have to write. So if I go in, wait, yeah, f of h, okay. So now if I go in from 0 to 10 and I type in my function, which is 50.3 over e to the 0.2 h plus h dh. What did I do wrong in part C? Okay. Oh my goodness gracious. I made a big mistake here when I typed this into my calculator. I did this so that you won't, I wasn't paying enough attention. So it's divided by all of this, right? Don't be like me. Make sure that you put your whole denominator in parentheses. That makes a huge difference in this. Oh, it turned off. Sorry, there was a knock at my door. Okay, so like I said a minute ago, be careful there. Let's divide by the whole thing. Make sure it's in parentheses. So doing that, we get the actual cubic feet. So, wait, this is not the right paper. Where did it go? Where did it go? Oh, it's under there. All right, so now I've got, let's see, 1.325 cubic feet. All right. So clearly from earlier, this was an overestimate. The 176 that we got was clearly an overestimate. Oh, I should address this too. So this needs to be 3 decimal places, or it's wrong. You may be asking, well, why not that one? Well, because they only gave us one, like our answer was only 1 decimal. You're fine. Okay, don't overthink it. All right, part D. Water is being pumped into the tank. Oh, that sounds like related rates. When the height of the water is 5 feet, do I know the shape of the tank? No, I don't. Okay. When the height of the water is 5 feet, the height, that's telling me that h is equal to 5. That's going to be important somewhere. The height is increasing at a rate of 0.2. Okay, so that's saying dh dt is equal to 0.26. So these are telling me, like, at this time, these are the conditions. Using the model from part C, using this mess from part C, find the rate at which the volume of the water is changing with respect to time when the height of the water is 5 feet. Okay, so we are going to be looking at the rate of change of this with respect to time. And it wants the rate of change of the volume. Okay, we are about to take a gigantic conceptual leap, as many part Ds do. So, I want the rate of change of the volume. What is the volume? The volume is the integral of our area. So if I look here and I go, nope, let's, so if I know that volume of H is equal to, from 0 to x of f of x dx, I know the volume is equal to the integral. So if I want the rate of change of the volume, I'm looking for the derivative of volume. Here's the great part. Oh, I'm sorry. I said h, this needs to say h. Here's the great part. Remember that this is the fundamental theorem of calculus. The derivative of an integral, you just drop that bound in. So v prime is equal to f of h. Remember, we just dropped that bound in. If there had been something there, we'd do f of h minus f of whatever that is. But since the only one of these that has a variable is h, we just drop that in. Okay. And we just want to know, Okay. I forgot one thing. So, all right, I would have gotten something wrong here. I would not have gotten this correct. So I dropped the h in, but since we're doing things with respect to time, not respect to h, I need to also do times dh dt. This is a related rates problem, and I forgot that. And knowing that, that's kind of a clue to us that we are gonna need to use that most likely. So if I want v prime of 5, well then I want f of 5 times dh dt, which is equal to 0.26. And f of 5 is equal to 50.3. So sorry. All right, so I just put in 5 to the function. So 50.3 over e to the 0.2 times 5 plus 5. Now notice how this time I actually have the denominator in parentheses. And so we get 6.51 whatever times 0.26, and we get 1.694, and it says I'm finding the rate of change of volume, so that's going to be feet cubed per our time, which was minute. All right, next problem.